Okay, so to carry this on, my memory card ran out, but I continued drawing it out. So the acetyl-CoA here, which comes from carbohydrate, fat amino acid oxidation breakdown, that passes through the cycle. After this enzyme step, you have succinate is created, and then succinate dehydrogenase succinate dehydrogenase converts succinate to fumarate. Fumarate is converted to L-malate by fumarase, and L-malate is converted to oxaloacetate, okay, by malate dehydrogenase, okay. So the enzyme malate dehydrogenase comes in here, which is kind of a bit difficult to see, but you got malate. Mal dehydrogenase. Okay. In this whole reaction, you got 1, 2, 3 NADHs created, okay? And you got one FADH, okay? So you got NADH, 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 and then you got an FAD here, okay? I should have done that in blue as well, that was a mistake. An FAD there, okay? So each of the 3 NADHs each have an electron pair, okay? Each got an electron pair. This is called the Krebs cycle, by the way. So the NADH have electron pair, okay? So 3 of those plus the FAD has an electron pair, okay? And then you got guanine triphosphate is made, which is essentially ATP, okay? Which provides energy. It's a high energy phosphate and that, high energy phosphate. So you get 4 pairs of electrons, 3 here and 1 from here, which are then put through, 4 pairs of electrons come from acetyl-CoA, and then they get put into the electron transport chain, mitochondrial in the membrane, which is then, hydrogen's also passed on, where they at least production of ATP, okay? So yeah, and so from you got 3 pairs of NADHs making 3 ATPs, and you got so 3 pairs of electrons from NADHs making 3 ATPs, and 1 pair of electrons from FAD making 2 ATPs, which is giving you 12 ATPs in one cycle. So okay, but overall, once the whole glycolysis, Krebs cycle and electron transport chain is finished, you get 38 ATPs made, okay? It is actually, the whole of this cycle is actually very complicated. The kinetics and energetics and thermodynamics of it is very complicated, and but this is sort of just an overview of it, of degree level. Okay. Yeah, and overall, yeah, and overall you also get 3 ATPs. So yeah, one of the outcomes of it overall is that you get 3 ATPs from a total of N of 10 NADHs are made, okay? And 2 ATPs from each of the 2 FADHs, okay? But this is, I'm giving you a rough summary of it, okay? hope you find this interesting and informative, and I could explain a lot more, but it would take a lot of video, probably in a few hours. But anyway, yeah, so you got a total of 1, 2, 3, 4, 5, 6, and 7, 8 enzyme reactions, okay? 1, 2, 3, 4, 5, 6, and 7, 8 enzyme reactions, okay? 8 enzymes involved. Thank you. I should also say there's so acetyl-CoA joins up with oxaloacetate to make citrate. Citrate is converted to a cis aconitase by aconitase. Cis aconitase is converted to isocitrate by aconitase. Water is released there, water is added there. Isocitrate is converted to this molecule oxalo, then there's that molecule by isocitrate dehydrogenase, so a hydrogen is removed. Then the oxalosuccinate is converted to alpha ketoglutarate by isocitrate dehydrogenase. Water, carbon dioxide comes off, loss of carbon. Then NAD plus is hydrogenated, and the coenzyme is used to create a CO2, remove the CO2 from there. Then alpha ketoglutarate dehydrogenase converts the alpha ketoglutarate to succinyl-CoA, and succinyl-CoA is converted to succinate with loss, with guanine triphosphate being formed and a coenzyme coming off. We're down to 4 carbons, by the way. Start off with 6 carbons and it goes down to 4. So acetyl-CoA is 2 carbons, oxaloacetate is 4. Those join together to form a 6 carbon. So at this point it's 4. Succinate is converted to fumarate by succinate dehydrogenase. FAD is hydrogenated. Fumarate is converted to L-malate by fumarate, sorry. Water is added, that's 4 carbon. Then L-malate is converted to oxaloacetate, okay? And with NADH again being hydrogenated. So the NADH and FAD go off the mitochondrial membranes electron transport chain, which is 4 separate enzymes. That's pretty complex as well. So yeah, this is an overview of the Krebs cycle. And yeah, acetyl-CoA can also come from fat and amino acid breakdown as well. But this is from glucose carbon. So I just wanted to clarify, I've written 8 enzymes here, okay? The citrate synthase, 1. Aconitase is 2. That's the same enzyme again, that's 2 enzymes. Isocitrate dehydrogenase is 3. I use the same colour as pen as I've written them in. So that's 3, okay? Isocitrate dehydrogenase is 4. Sorry, that's 3, it's the same as that one, that's 3 enzymes. Then one called, there's alpha ketoglutarate dehydrogenase is 5, okay? That comes in here, so it's 5, so that's 1, 2, 3, 4, okay? And then it should be one here called succinate-CoA synthetase. Succinate, synthase, okay? So you've got 1, 2, 3, 4, 5, okay? 6 succinate dehydrogenase, 7 fumarase, okay? And 8 malate dehydrogenase. So there's 8 enzymes overall. There's 8 different enzymes, but some of them are repeated. Citrate synthase is unique. Aconitase is repeated. isocitrate dehydrogenase is repeated. There's 1, 2, 3, 4, 5, 6, 7, 8 enzymes, okay? So in the clarified, it's 8 different enzymes, but 2 of them are repeated, okay? They're sometimes named after the product, the reactant rather than the product. Depends which way you go. Okay, yeah, Krebs cycle is pretty complicated, but I hope you find that interesting.